Hey everybody! In today's video, I wanted to talk about data-driven decisions in API simulation. Specifically, how do you make virtual services that can decide on how to respond based on varying requests, using data objects, or using decision-making criteria within the virtual service itself? For those of you who are not familiar with API simulation, in today's complex environments, it's all too prevalent that when you're trying to test an end-to-end flow, you are going to be caught off guard by the number of dependencies that exist in an environment. And while these API dependencies may be out of scope for the testing for end-to-end on that blue series in the middle, you need them in order to have complete test environments. And so service virtualization is a stand-in for services that are unavailable, unstable, or lack proper test data. But one of the things we like to joke about in API simulation is that while service virtualization makes it easy to create on-demand environments that are available for your testing, environments tend to not look like this. They look like this. And for many of you who have watched other videos in this series, you know this is not a new message. But actually, it makes a lot of sense in the context of data-driven decisioning within your virtual services. Because if you're going to make a virtual service that accounts for something inside of a giant machine like this, it's got to be pretty intelligent to stand up to the complexities of a modern test environment. And so there's a couple of different ways that we can make decisions. In previous conversations, we've talked about making decisions at the transport layer, using a proxy with the various modes. Making a decision at the transport layer means that when a message comes into your service virtualization tool, you can decide to go to the real service, or you can decide to go to the virtual service depending upon triggering that we call failover triggers and modes inside of connections. But I want to talk about something a little different today. I want to talk about once you've done something like that, where you've made a failover decision to say, okay, I am not going to go to a real service because it's offline. I'm going to go to a virtual service. I may then have other messages in my sequence that do things like this. If a certain condition, give this response or something else. And then if all else fails, do this. And these can be different responses that can come from an individual virtual service based on the incoming request information. And so I want to show 3 examples today of how we can do data-driven decision making. And actually we're going to look at 2 different types of data-driven decision making. Probably needs a new name. The first type is what you see on the left-hand side, where services have very specific conditions, waiting for information to come into them, and then they spin back a response. On the right-hand side, it's more of a data lookup based on conditioning that comes in. They're roughly the same thing, but they have different manifestations. All right, let's jump into product. And so what I'm going to do is I'm just going to open a simulator, and I have 3 services ready to go here to talk through this scenario. The first one is a service where what I want to do is make a query to my service and have it look up data in a backend data object. Okay, let's actually go to the play page and start interacting with this service. So I based this service on Harry Potter and the notion that maybe Harry Potter has some kind of a data lookup system, right? They have to keep track of all the users in the Ministry of Magic. So in this case, I gave it in my request an ID of 1, and it returned back to me Harry Potter. But how many witches and wizards do you think exist inside of the Harry Potter universe? The answer may surprise you. If we go and we turn off our filter and we jump back into our data object, we can see the Harry Potter CSV file, which has a staggering 138 different witches and wizards. And you'll notice all the witches and wizards have different characteristics. There's a ton of information about each individual wizard. And so what I want to do is I want to create a service that does a lookup for the ID of that and then returns all of the response information into my response object. so that as I look up different witches or wizards, so in this case, we'll look up this guy. We'll go ahead and just look up a different witch or wizard here, and then I can toggle that back and forth to the different witches and wizards. I'm actually going to copy this out, and we'll do it up here so that we can quickly change it. Here's what we get for 1. I'm going to go ahead and put in 99, and we'll see that we get a different response. All right, how is that working? So inside of the service, and I'll supply all of these as examples, I have indicated a resource. A resource can be different things. A resource can be a table. It can be a CSV, a CSV file. It can even be an embedded data source that we have inside of our service. Here I'm connecting to a CSV file that I can read and write to. Then when you make your service trigger, you simply need to capture some criteria. In this case, I'm looking at the request ID. And then I'm using a query, which we're going to be looking at a lot, which allows me to do a data lookup. In this case, the syntax is, whenever I look up a name for my response, I need to get the name from Harry Potter's CSV, which is the name that I've given the resource. Where is really important here, where ID equals the incoming ID. Give me the name column. Same thing here, give me gender, job, house. And so what this does is the request comes in, it gets the ID, it then goes and does a data lookup in that particular resource, and then returns the value of name. In this case, if I were to go to that CSV file, which I have here, and I were to look at it, it would say, here's the ID, here's the name, and so on and so on and so forth. And through that, you can data drive your virtual services from a data object, and it makes for one service that can handle hundreds of different use cases, request and response. Okay? But there, as I said, were other types of decision-making criteria that you can make. The second one I want to talk about today is conditions triggers. So what happened in that first service was that I decided that messages were all captured. I would then grab the ID and then data look up the response object. But you can make that same decision-making criteria in the initial trigger. Here's an example. I have 3 services, one with an OR condition trigger, one with an AND condition trigger, and one with an AND/OR condition trigger. What I want to happen is that depending upon the request that I send, and in this case we're just going to be sending some books in, depending upon that evaluation of that incoming request, I want to either trigger or not. And we can take advantage of something called exists true here. Now in your standard trigger, you're going to say that the first name is John and the last name is Doe. But in this case, what I'm doing is I'm using my JSON path to find certain selections within the incoming request and either correlate them to static values, or we'll look at data values in a later service, and make a decision. In this case, I'm saying that if the book comes in and the category is drama, or the price is greater than $20, then send this request. And so you can put that decision into the trigger itself. If these conditions are met, it will serve up the response. If not, it'll move to the next one, and the next one, and the next one. And so I've actually put all of these into a little contract test. So let's just see this one in action. And so what's happening here is that I will go and say, all right, the trigger is looking for the category to be drama or the price to be less than 20. And so here I have comedy as the category, so that's not right, but the price is less than 20. So if I were to send this request off, I would see success, you got an OR condition. If I were to come back in here and I were to change this to drama, and I were to make the price higher, for example, $33, and send a request, sure enough, I would also get the OR condition. But if neither of those met my conditions, and I were to hit request, I would get no service matched because nothing matched on that particular OR. The AND is just a, in my opinion, more simplified version of this, where it's looking for both this or multiple types of information. In this case, it needs John Doe to be the first name, and the price has to be greater than or less than $30, which it is. John Doe less than $30. That gives me my and we could go through that same exercise and break it, but I think you get the point. This one's kind of interesting, and or. So in this particular case, I am looking for a book that has the price greater than 20 and a category of fantasy or rating of 4.5. Now this is actually, this condition on the right hand side is actually an or, and it's sitting next to an and. So you can think of this as it must have price no matter what. If the price isn't greater than 20, goodbye. But if the price is greater than 20 and one of these two conditions is met, then I will be able to serve up a response. So in this case, what I'm saying is that the price is 45, or the price is 45. Okay, great. That means that the first part of my condition is met. Then my second one is fantasy or 4.5. Well, it's both of them. And so if I were to break this fantasy, it would still work because of the rating. And if I were to then go and reduce the rating to put it less than 4.5, then it wouldn't work because only one of my conditions is met. If I were to come back here and I were to say, okay, both of my OR conditions are met, but my price is not greater than 19 or not greater than 20, I get my OR condition. Why? Because the OR condition says price less than 20. And I did this deliberately because you have to be really careful about using conditions in your services and make sure that you put your strictest conditions at the top and then put your looser conditions as you work down. But regardless, through this technique, you can use conditions in your triggers in order to evaluate and make decisions on which messages to respond to. All right, let's talk about the third type of decision making, and that is using this same concept, but also looking up data in a data file. So in this service, what I want to do is I want to receive a request that looks like this. And then I want to evaluate each of the individual elements. And I'm going to have a matrix correlation in my data source with different conditions to determine whether I should both trigger and respond to this message. Sounds complicated, but it's not. The idea is that when the message comes in, it's going to grab buffer A, buffer B, and buffer C. And then what it's going to do is it's going to look up in a resource, in this case, a CSV file called data-driven CSV. Let's go ahead and look at that. And I'm just going to open up another tab and unfilter, go to my data, and grab my data-driven CSV, because this is going to be really interesting to look at as our services are going are being correlated. And so I'll just kind of shrink this down and put it over here. And so this is my decision-making criteria. I've got a row number, I've got an A, I've got a B, and I've got a C, and then various kind of data in those. And so, okay, let's look at this. This says that A equals A and B equals B, or that C equals C. And so let's go ahead and look at the play message and talk this through. So data, decisions, decision where test. So now, if I send this request that says to an A, B, C, and D, that will match row 1, because remember, it's A and B or C. And so in this case, I should receive row 1 for this, but I have a problem, and that is that C will actually match the column that's in that last one, and OR will always take precedent over the AND. So let's change that. Let's change this to FF. Okay? Now what should happen when my request comes in is that I should only have A and B, which will give me row 1, And in my response, I'm asking for the row number. But you could put back a data file or what have you. And so if I send this request in, bloop, I get row 1. Now, let's change that. Let's give it only this C, which is if it equals this C, then it will respond regardless of what's in A and B. And so to do that, I'm just going to make this, 444, and I'll make this E, but I'll give myself a D here, which means that that OR condition will be met, and D will take the row 3. And so you can use these 3 techniques in different combinations to achieve the kind of logic that you're looking at for your service, either by statically defining the conditions in the service themselves to return, or by having that condition either be a direct data lookup, and then the data then overrides the response, or do conditional lookups dependent upon criteria with ands, ors, or and/ors in your service. And you can use them in combination to make very intelligent services that make decisions and minimize the amount of lines of code that you have to write in your individual services. Hope you found this informative. If you have additional questions, go ahead and take a look at our resource section on tricentis.com, or check out the API simulation product for more information. Have a good day.